Welcome to this video on Stencil fundamentals. My name's Carl and we're going to understand what Stencil is for a start. So Stencil's a library that helps us create web components, so standard web components, which is great because it means we can use those components in any HTML based application. And it allows us to use modern constructs like JSX and TypeScript to create the components. So it allows us to create the components quicker and more robustly than it would do using the native DOM APIs. And the other big selling point of Stencil is that it'll polyfill browsers that don't support web components yet, which are Edge and IE. So it allows us to create components using modern constructs really quickly, targeting any major browser. So this all sounds pretty cool. Let us try it out. We're in VS Code. We're going to create a new Stencil project using the init stencil npm command. We then get to choose the project type, which is going to be components, because we're going to create a couple of components. We'll give the project a name and confirm that, and then it very quickly creates our project. The project contains an example component, so we can start to get comfortable with what Stencil components look like. So we can immediately see that they're strongly typed with TypeScript. We've also got a HTML page in our project as well, where we can test the consumption of the components as well. To run the project, we can use npm start in the right directory, and after a few seconds the HTML page opens with our rendered component. Let's hop back into our Visual Studio Code project and we'll start to build our very own alert component. We've started by copying the example component and renaming it my alert, and we're removing the component tests and the readme file for now. Our component CSS is fine to be empty for the moment. We're going to remove all the example code from the component, so we're just left with the bare minimum. The tag name for the component is going to be my-alert, and we specify that in the component decorator. A method called render is where we define what is output to the DOM from the component, and we use JSX to define that. We're just going to output the text, "This is an important alert." The final thing that we need to do is name our class myAlert. Let's save the file and then let's go over to our index.html and let's consume our component. Save that. If our app's not running, we can do an npm start, but if it is, we can simply flip over to it and we'll see our components rendered. So we've implemented a very basic component there. We're now going to make the component a little bit more flexible. We're going to use props to allow the consumer to configure the text. So let's go back to Visual Studio Code and go back to our component and import the prop decorator from Stencil. We can then use that decorator to create a text prop, and we'll default it to "This is an important alert," and then we can reference that prop in our JSX. And if we look at the rendered page, we get "This is an important alert" because that's the default text for the component. But if we change the consuming code in our HTML file to pass in some different text, then we'll see that different text rendered on the HTML page. We can interact with the text property through JavaScript as well. So let's add a button, and when that button's clicked, let's change the alert text. So we've opened up a script tag, we've got a reference to the button. We're going to create an event listener on the click event. And in that event listener, we're going to get a reference to the alert. And then we're going to set the text property to "This was a very important alert." So let's save the file. We'll go to the rendered page, click the button, and we can see that the text has changed. So one very important thing to understand is when the props change, the component is re-rendered. Let's move on to component styling now. So let's go back to VS Code. We'll go back to our component and we can specify the CSS file that the styles are in using the style URL in the component decorator. We're going to change our component to render a paragraph tag rather than a div tag. We're just then going to go over to the CSS file and give that paragraph tag some style. So if we now go back to the rendered page, because we've introduced that new CSS file into our build, we'll refresh the browser and we can see our style coming through. So this is looking fantastic. As well as being able to encapsulate behavior, we can encapsulate styling as well into our components. But let's double check that that style is encapsulated. We're going to add another paragraph tag under the button with some text in. Let's save the file, look at the rendered page, and we can see that the style's leaked out. So what's going on? So let's inspect the style using DevTools, and we can see our paragraph, we can see our style being associated with it, but we can see the style is coming from a global style tag that's obviously going to get picked up from all the paragraph tags on the page. So at the moment the component isn't encapsulating the styles. So what we can do is switch the shadow DOM on in our component, and that should encapsulate the styles. We do that in the component decorator. We simply set shadow equals true. We want to have a look at this in IE as well as Chrome, so let's run in prod mode, and we can do that with a -- prod after npm start in the terminal. It'll take a few seconds to start up, and that looks like it's worked. So let's go and inspect in DevTools, and we can see our paragraph tag is inside the shadow DOM, so the styles aren't leaking out. We're going to take a copy of the browser path and have a look at this in IE. And remember, IE has no shadow DOM, and that seems to have worked, which is good news. So let's inspect the DOM. There's no shadow DOM as we expected. We can see a class has been injected on a paragraph tag and the style has been scoped with that class. So Stencil's using scoped styles as a workaround for not having the shadow DOM in IE. But let's think about the shadow DOM and what that means for consumers. What if they do want to style internal elements within a component? So in our alert, what if they wanted to increase the font size? At the moment they can't really do that. What about automated testing and element selectors that we write in our test scripts? Let's try and select the paragraph tag within our alert. We can see that's not returned when we try and select it. That shadow DOM is hiding it from us. So the shadow DOM does cause knock-on problems. We could use CSS properties for the styling, but that is a bit glitchy in Stencil at the moment. Automated testing tools though really struggle with the shadow DOM at the moment. So let's go back to our component and replace shadow with scoped in the component decorator, and that should make the styling behave how it was behaving in IE. We're going to restart the project and make sure all those changes make it into the build. It'll take a couple of seconds. So we can see that appears to have worked. Let's inspect the style and we can see that we've got a scoped style now. And if we check in IE, that's working as well. Great. So let's just query and select that paragraph tag within our component. And as I expected, we can get to that fine. So we don't need to do anything special within our automated testing. So one of the biggest, most important decisions that you're going to make when creating a web component is whether to use the shadow DOM or not. And think about the automated testing. Do you need to do that? Think about styling. Do you need to let consumers style it? If those answers are both yes, then it's worth considering not having the shadow DOM in the component. We're going to move on now. I'm going to give our component a bit more flexibility. We're going to have a kind property, and that can be info, success or error, and that will dictate the background color of the alert. We'll default the prop to info, and we're going to use that kind prop value as the class name on the paragraph tag. And in our CSS file, it means that we can have different rules for the different kinds of alerts. So we'll remove the colors from the main rule, and then we'll add the different kinds and their colors. We're going to go to our HTML file and let's consume this kind property. So we'll have one alert that's info, one that's success, and then one that's an error. And if we have a look at that, that works nicely. So mapping a prop to a CSS class is a neat way of varying the style for different prop values. Before we move on to our next topic, we're going to clean up our index HTML. We're going to get rid of the button and we're going to get rid of all the JavaScript. So all that's left is our 3 different alerts. On to our next topic, which is going to be state. And these are local variables within the component that when changed will cause the component to re-render. And these are useful when the component needs to be interactive. So in our alert component, we're going to add an acknowledge button, and when the user clicks that button, the alert will hide. So we're going to start by importing the state decorator from Stencil. We can use that on an acknowledged Boolean variable that defaults to false, but when it's true, that should hide the alert. We're now going to rearrange our JSX slightly before adding our acknowledge button. Now when the button is clicked, we want to change that acknowledged state value. So let's create an on-click handler. We use an arrow function for the handler so that we get access to the class instance using this. So we can simply set our acknowledge state to true. The styling on the paragraph tag is going to get more complex because it's going to depend on the acknowledge state as well as the kind prop. We're going to extract that logic out to a function. We're still going to have the kind class, but if the alert is acknowledged, we're going to add an acknowledged class. So now we can reference that function on our paragraph tag. Before we move on to define the CSS, let's make a few corrections in the function. We need brackets around the acknowledge bit in the function, and acknowledge needs a D on the end. Add in our CSS then. When the paragraph tag has got the acknowledge class, it's not displayed, and the acknowledge button is borderless and it's got small faint text. So let's give this a try. We're going to get rid of some old browser tabs. We'll refresh and then we can see our acknowledge buttons, and if we click those, the alerts disappear. To prove to ourselves that the component's re-rendering when state changes, we'll console log the word render in the render method. We're going to make sure we're running the dev build rather than the prod build so that we can see those console log messages. So npm start to do that. Wait a few seconds. We'll open up DevTools on the console and we can see we've had 3 renders from our 3 alerts. And when we click the acknowledge button, we get another render. And that proves that changing state re-renders a component. I'm just going to remove that console log now before we go on to our next topic. And our next topic is going to be events, so exposing events from our component. And the example that we're going to do in our alert component is an acknowledge event that will tell consumers when an alert has been acknowledged. So we'll start by importing the event decorator and the event emitter type from Stencil. We can then use those to declare our acknowledge event. We then raise the event by calling emit on that event variable. So the event is being raised when the acknowledge button is clicked. Let's listen to that event then in our HTML page. We're going to listen on the document so that we can catch the event for all 3 alerts. And we're just going to log out the alert text to the console in the event listener. And if we give this a try and acknowledge the alerts, we'll see that the text is output to the console. Let's enhance our event to have an argument, and the argument will contain when the alert was acknowledged. We start by creating an interface for the argument type. It's important to export the interface, and in our case we're just going to have a when property that is of type date. On our acknowledge event property, we're going to pass in our argument type to the event emitter type, and then when we emit our event we can include the value of the when property. So in our HTML page, let's include our event argument, which is in the detail property. And this is the case for any component event that we create. Our custom arguments for that event are in the detail prop. So if we give this a try, acknowledge the alerts, we'll see that the date and time is logged out to the console. Our next topic that we're going to look at is listening to events. And we've seen how we can listen to events on internal elements, but how can we listen to events on the host element? So we're going to change our implementation so that the user can click anywhere in the alert to acknowledge it. So as part of that, we're going to need to listen for a click event on the host element. We can do that using the listen decorator, so let's import that. And then in the decorator we say what event we want to listen to, which is click, and the decorator decorates a method that's going to handle the event. And we need to change that from an arrow function to a normal method. We'll give the method a slightly different name as well. We no longer need an acknowledge button, so we're going to change that to a span. And we'll tweak the CSS to target a span instead of a button. And because it's a span, we don't need to remove the border. And if we give this a try, we'll click the acknowledged text and it disappears. We'll click anywhere else in the alert and it also disappears. Good. Our next topic is lifecycle methods. And these are methods that we can implement in our component to execute logic at various points in the component's life. And this page in the Stencil docs shows us these methods and when they get invoked in the lifecycle. We've already used the render method. The other method that's heavily used is component did load, and that's after the first render when the component's been loaded into the DOM. And component did update occurs when some state has changed or a prop has changed and the component re-renders and updates. So we're going to have a little play around with both the component did load and did update methods in our alert component. So we're simply going to add these methods to our alert component and output fully loaded to the console when the component's loaded, and then component updated when the component's been updated. We'll give this a try. And we'll see straight away we've got our components fully loaded, and then when we acknowledge the alerts we get the component updated logged. And we're just going to remove those lifecycle methods now because we don't actually need them in our alert component. We're going to move on now to create a more sophisticated component. In fact, it's going to be a compound component, so that's two components working together to create a sophisticated user experience. We're going to create a tabs component, and one component is going to be the container for all the tabs, and then we've got a component for the tabs themselves. And we're going to start by focusing on the individual tab component. So we'll copy our alert component as a starting point and we'll clear the stuff out, and this component is going to be called my tab. We'll start by thinking how we want our component to be consumed. So in our HTML page, let's just write out an instance of the component. We want a name prop to uniquely name the tab, and we also want to specify what is rendered within the tab. We'll create a second tab, give it a different name, and this time we'll render its caption in bold. We also want to be able to specify that a tab is active, so let's add an active prop to the second tab. We'll start the implementation then. Let's import the prop decorator so we can add the name and the active prop. Nothing new there, we know how to do those. We're going to render a div that's got a CSS class on it, and the class depends on whether the tab is active, so we're going to use a function to calculate that. So the div is always going to have a my tab class, but if it's active, it'll have an active class as well. So we can add the CSS then. So we're going to give each tab some padding and a pointer cursor, and then active tabs will have a blue underline. And if we have a look at the output in the browser, we see that coming through. But if we look a little closer by inspecting the DOM, we will see that our tab caption is outside the div and not inside the div. So in our component, we need some way of saying this is where we want the child content to be rendered. Luckily, there's a way to do that, and we can use what's called a slot to do that. Nice and simple. Let's give it a try, refresh the browser, and we will see now that our tab captions are within our div. So our next job is to add a tab activate event when the tab has been clicked. So we'll start by importing the bits and pieces from Stencil. We'll create an interface for the arguments, which is just going to bring back the tab name. We'll then declare our event variable, passing in our argument type. And we want to listen to when the tab's clicked. So let's create a handler for that. And then when it's clicked, we want to emit that tab activate event, including the tab name. And let's not forget to make the tab active as well. Let's consume that event then in our HTML page. I'm just going to comment the alerts out so that we can see our tab more clearly. And again, we're going to listen for the tab activate event on the document, and we're going to output the tab name when that's been raised. We get access to the tab name through the detail prop in the event argument. So we'll give it a try, have a look at the console, click the tabs, and we can see the tab name is being outputted. We can also see the tab being activated as well with the active style. So we're making good progress, but we only want one tab to be active at any one time. So we could do with a component that wraps around our tabs and manages which tab is active. It would be nice to specify what tab is active by default as well, using an active tab property. So let's implement this. We'll close the files down, and then we're going to take a copy of our mytab CSS and mytab TSX, and we're just going to rename those mytabs. So we'll clear out the CSS, and we're going to clear everything out of our component, but it's going to be named mytabs. We're going to start the implementation by managing which tab is active. So let's import the listen decorator and the argument for the tab activate event, and we'll create a listener for that event. We can strongly type the event listener argument by using the custom event generic type and passing in our event type. It looks like we've not exported our tab activate event, so let's go and correct that. Now everything's compiling fine. We're going to leave that handler there, and we're going to go to the render method. We're just going to render a div with a slot inside, so that's just going to render the tabs within it, and we'll give our div a class name as well. So let's think about our tab activate handler again. Somehow we need to get all the tabs and make sure the one that's just been activated is the only one that's active. So it would be handy to get a DOM reference to our host element, because then we can do a DOM query within that to find all the tabs. So the way that we get a reference to our host element is using the element decorator. So let's import that, and then we can declare a variable with that element decorator that's going to give us a reference to the host element. So let's have a lowercase e for element, and we can use our element variable to get access to our container div, and then we can get the children within that div. We're then going to turn this result into an array so that we can use the filter method to just filter out anything except for the mytab instances. And let's make that check case insensitive. So we've got our headings, so let's loop around all those headings, and we'll deactivate all the tabs that haven't just been activated. We'll give it a try then, refresh the browser and click on the tabs, and we can see that the activation is being managed nicely now. Let's add a little bit of styling, so let's go over to our CSS file, and we're going to turn our div into a flexbox. So if we go back to the browser and refresh it, we'll see that we've got horizontal tabs now. Let's go to our HTML file, and we're going to remove that active property, so none of the tabs are active by default. Let's go to the browser, so we have to click on a tab to make one of the tabs active. To improve the consumption, we're going to make the first tab active by default if none has been specified. We can use the component did load lifecycle method to do that work. We're going to need to get our tab elements again, so we're just going to extract the expression that we had before into a function. So now when the component's loaded, we can get the headings, check if one of them's active, and if not, we can set the first one to be active. But we only want to do this if there's more than one tab. So let's give this a try, refresh the browser, and our first tab is active, and the activation still works nicely. Moving back to our HTML page, we'll see that we've got that active tab property on the My Tabs component. That's not implemented yet, so let us implement that now. We'll start by importing the prop decorator. We're also going to import a watch decorator, which we'll use a little bit later on. But we'll create a prop first. And we're going to make our prop mutable because we're going to change its value in the tab activate event. We're just going to comment out the previous implementation. So when our active tab changes, we want to set the active prop on the tabs. So we can create a watch on active tab and then a method that is going to handle changes. So we'll start by getting all our tabs again and setting the active prop on each tab accordingly. We can remove the commented out content in the handle tab activated method. And we're going to refactor our component did load event to be driven from the active tab property now. So if it's undefined, we do what we did before. If it's got a value, then we call our change handler, passing in the active tab. In that first branch, rather than setting the active prop on the first tab, we're just going to set the tab's active tab name, and it'll be the change handler that sets the active property on each tab. So we're ready to give it a go. Let's just go to our HTML file. So the second tab should be active by default, which it is, and we can still click the tabs and they work perfectly. So let's have a quick recap then. In components, we've got props that allow us to configure the component. We can watch props and handle changes to those. We can change a prop internally, and whenever a prop changes, whether it's externally or internally, the component will re-render. We can get access to the host element using the element decorator, and then we can use the DOM API to manipulate the component at runtime, perhaps in a lifecycle method such as component did load. The component is styled using CSS, and props and state can drive the CSS class names that elements have. We can expose events using the event decorator. We can listen to events on the host element using the listen decorator. And state are internal variables that, when changed, force the component to re-render. And all these features give us phenomenal power to build standard web components that can target any major browser. And that concludes the video. Hope you enjoyed it.